Okay, today we're going to continue our lesson on conics. This will be the last one for this unit, so it's going to be 2.4b. We're going to continue our study of hyperbolas. This time we're going to give you pieces and parts, and you're going to have to come up with a graph and then fill in all these pieces and parts down here. All right, so example 1 is telling us that we have a center at 0, 0. We have a focus at -3, 0. And you may want to label these just so you're sure about which points you're putting on there. And we also have a vertice at 2, 0. All right, so we know the center is 0, 0, so we have no minus h minus k. Since the focus and vertices are all lining up horizontally, this is definitely going to be an x squared hyperbola. They're always set equal to 1. The a value is the distance between the center and the vertices, so I know my a value is 2. The distance between the center and the foci will be our c value, which in this case is 3. What we still don't know is the co-vertice here, and that's the piece that we are looking for. As far as the graph goes, the center will be in between the two vertices, so I'll have another vertice here, I'll have another foci sitting over here. We do know the a value is 2, so that's going to put a 4 underneath the x for the a squared piece of it. I'm going to go ahead and find the b squared. For the hyperbola, it is a squared plus b squared is equal to c squared. A squared would be 4, b is what we're looking for, c squared would be 9. So I know b squared would be equal to 5, and then the b would be root 5 over here. So there's the equation that we got, so you need to get that equation. Our foci are sitting at, let's see, plus minus 3, 0. I'll work on the asymptote in a little bit. Our vertices are at plus minus 2, 0. And root 5 is about 2.2. So I'm just going to guesstimate that. 1, 2, and just a little bit more. 1, 2, and just a little bit more. All right, so our co-vertices are at 0 plus minus root 5. Remember, guys, no decimals, so we're looking for exact answers here. Once we have the pieces in the vertices and the co-vertices, we can go ahead and make our box. Again, the box is not part of the graph, per se, so we're going to keep that as a dotted line. Once that's in there, we need to get our asymptotes into the graph, and they're going from corner to corner through the center, just like this. And it's these asymptotes that help us to guide how the hyperbole is actually being drawn. Once we've got all that in there, we're going to go ahead and put the hyperbola in there, going from the vertex and hugging along the asymptotes. We are asking for the equation. Now we're going up root 5 and over 2, and in the other direction, down root 5 over 2. So our equation here is going to be y is equal to plus minus root 5 over 2x. The major axis, I'm looking for the equation here, so it's going to be y equals 0, and the minor axis is x equals 0. Okay, so let's move on to example 2. Down just a little bit. Again, we just want to kind of get the points onto the graph that have been given to us. So I got a focus at 0, 6. These are going to be going by 2's here for this. So our units are by 2. So 2, 4, and 6, there is a focus. And also telling us I have a vertice at 0, -2, so there is a vertex there. And also one at 0, 2. So they gave us the two vertices. Remember, the center of the circle will be directly midpoint in between those two vertices. So again, we're looking at a 0, 0 center. It gave us the two vertices here, so I'm at 0 plus minus 2. The foci also are equally, the center's right in between, so we're going to go 2, 4, 6 down here will be another focus, so that's going to be at 0 plus minus 6. So the a value is 2. I also know that we have a c value equal to 6, and again what we're looking for is our b value. I can see since the focus and vertices are all lined up vertically, that this is going to be a y squared. This is going to be a y squared parabola here. So so y squared minus x squared is equal to 1. I know my a value is 2, so that's going to be a 4. Let's go ahead and get that b value. So a squared plus b squared is equal to c squared. 4 plus b squared is equal to 36. B squared is equal to 32. And then we are going to wind up with a b value equal to 4 square roots of 2, and the 32 goes there. So we have our equation there, which is great. 4 square roots of 2 turns out to be about 5.6. We need the decimal for graphing purposes. So 2, 4, 5.6 would bring us about there. 2, 4, 5.6 would bring us right about there. Once we have, our, again, like I said, our vertices and our co-vertices, we can go ahead and get our box in there. Again, that's a dotted line, because it's not really part of the graph. It's just there to help us to get the asymptotes. Once that's in, let's go ahead and put the asymptotes in there. So we're running through the corners of the box, through the center. Another one's coming along this way. And do the best you can to keep those guys straight. So let's fill in what we know here. So for our co-vertices, we are at plus minus 4 square roots of 2, 0. When I'm looking at this here, we need to get the equation of slope. We're going up to, let's do this here, so that going up to and over 4 square roots of 2. So that would reduce to 1 over 2 root 2, which then would need to be rationalized. So we're going to go ahead and multiply top and bottom by root 2 over root 2, and that's going to get us root 2 over 4. So our asymptotes here is going to be y is equal to plus minus square root of 2 over 4x. We're looking at the major axis here. This is x is equal to 0. The minor axis, the equation is y is equal to 0. And then let's kind of look at the graph itself. So let's put the actual hyperbola on there. It's going to be a nice wide one, kind of working like this. And then another one coming down, just like that. Okay, so let's go ahead and move on to example 3. Given different pieces of information, the whole goal here is to make sure we can get our graph going. So they gave us a foci at 0, -2, and 0, +2. So those are 2 foci sitting there. That will place the center right at the origin at 0, 0. The foci were given. All right. It also gave us the asymptote to the line, y is equal to -x. So starting here, down 1, over 1, up 1, over 1. So that's what I was given for that piece of information. That means we're also going to have another one going in this direction here. So we get those guys onto there. So our asymptotes here are y is equal to plus minus x. So I know at this point that a is equal to 1. Actually, I don't know that at this point. I do know that the c value is equal to 2. And I do know that a squared plus b squared is equal to 4. Because I'm looking at this, it's a over b. So if I kind of go up here, we definitely have a y squared parabola. So we're going up 1 over 1. So I do know that the slope is going to be a over b. Write this. And I do know that that slope is equal to 1. That means a and b have to be the same number. So I could replace this b with a. So a squared plus a squared is equal to 4. 2a squared is equal to 4. So a squared is equal to 2, which would mean both a and b would equal root 2. This is a y squared hyperbola, and we can tell that by the way it's going this way. So it's going to be y squared minus x squared is equal to 1, and both these numbers wound up being 2. Square root of 2 is about 1.4, so I'm going to try to get that onto our graph here. So up 1 and a little bit more, down 1 a little bit more, same thing in the other direction. We can put the box in there. We already have the asymptotes, but you can kind of see how that, let me go up a little higher, is coming along here. And then the last thing we need to do is actually put the hyperbola in there just like that. Alright, so let's fill out what else we know. We know the vertices are at 0 plus minus root 2. The covertices are at plus minus root 2, 0. The major axis is running this way here, so that is going to be the line x is equal to 0. And the minor axis running through the covertices this way would be y is equal to 0. Alright, so let's flip our pages over. Let's see what else we have here. So example 4. Our center is now shifted off the origin, so we just want to be conscious of that. So we have a center at 1, 4, so 1, 2, 3, 4. There's our center. They tell me I have a focus at negative 2, 4, so there's a focus, and a vertice at 0, 4. Okay, since the focus, vertice, and center are all lining up horizontally, this is going to be an x squared hyperbola. We do need to take into account the shift off the center. So now it's going to be x minus 1 squared, y minus 4 squared. The center will be in the middle of the two vertices, so I'll have another one over here. And then the focus is 3 from the center. 1, 2, 3. There'll be another focus sitting over here. So far we know we have a center at 1, 4. I have foci at negative 2, 4. Also at 4, 4. I also know that I have vertices at 0, 4, and then 2, 4. I can see that our A value is equal to 1, our B value we don't know, and our C value is equal to 3. So, using our A squared plus B squared is equal to C squared, we have 1 plus B squared is equal to 9. B squared is equal to 8, meaning B itself would be 2 square roots of 2, and that's about 2.8 for our graphing purposes. Since our A is 1, we don't need to put a 1 underneath here. It simplifies just to x minus 1 squared. This guy would be over 8, so there's our equation. We are looking for the equation as well. The B value is about 2.8 coming off the center. So 1, 2, almost 3. 1, 2, almost 3. Once I've got those pieces in, now it's time for our box. Do the vertices and the covertices. Once the box is in, now it's time to put in our asymptotes. So this is a pretty steep one going that way. Try to do this as straight as I can, going in the other direction. And that's going to help us to guide our hyperbola going through the vertice and hugging along the asymptotes. You'll notice the further the focus in, the wider this parabola becomes. Let's go ahead and look at our equations here. We do need the point-slope formula of y minus y1 is equal to the slope times x minus x1. And the point that we're going to use for the x1, y1 is our center point over here. So we're going to wind up with y minus 4 is equal to the slope. Now the slope is going up 2 root 2 over 1. So up 2 root 2 over 1 would just be plus minus 2 root 2 x minus 4. So there's the equation for our asymptote. Our covertices are at 1 plus minus oh boy, 1 plus minus 2 root 2, and the y-coordinate is 4. No, I did that wrong. I apologize. We're going up and down. We need to bounce off the y. So we're going to keep the x-coordinate of 1, and it's going to be 4, and then we're adding up to root 2 and down to root 2. I apologize about that mistake. The major axis in this case is the line y is equal to 4. That's where the focus and all that's running through. And our minor axis is at x is equal to 1. Okay, let's move on to example 5. Okay, this time they're telling us that we have vertices at 1, negative 3. 1, 2, 3, there's a vertex. And we also have one at 1, 1. So there's another vertex. We can get our center point. That will be the point just completely in the middle there. So there is our center. So our center is at 1, negative 1. My vertices were given 1, 1, 1, negative 3. It's also telling us I have an asymptote at y plus 1. Don't really need the parentheses there, but it's okay if they are. Plus minus 3 halves, x minus 1. So since we're running up and down this way, I know my a value is going up, my b value is going to the right over here. So from this, I can gather that my a value is equal to 2. I can also gather that I don't know my b value at this point. I do know, let's see, a over b is equal to this slope here. So let's go ahead and get the b value. Let's see, that'd be 2 times a, but I know what a is, so let's substitute that with 2 is equal to 3b. So 4 is equal to 3b, so b is equal to 4 over 3. All right, so I know my b value now is 4 over 3, so that's about 1 1/3, so that's going to be about here and then here. So my co-vertices are sitting, now we're going left and right, so we're going to bounce off the x-coordinate. So this would be 1 plus minus 4/3, keeping the y-coordinate there. Let's go ahead and get our box in now. Go through the co-vertices and the vertex. Once the box is in, that's a guide for us to get in our asymptotes. Again, all that is dotted. We're definitely looking at a y-squared hyperbola. I've not written the equation yet, but I will in just a second. So that's going to be going up like this, then down like this. Our foci, if we think about it, we're going up. Let's think about this. So we're going up 2 over, let's get that equation, here. So we're going up 2 and we're going over, let's see, how much are we going over? We haven't gotten the foci yet. So let's get that now. So a squared plus b squared is equal to c squared. I know this is going to be 4. This is going to be 4 over 9. That's going to be equal to c squared. If I change this over to match the fractions here and combining these guys up, I'm going to wind up with 36 over 9 plus 4 over 9. And that's going to, oops, that should have been 16, sorry, 16 over 9 is equal to c squared. So that's going to leave me with 52 over 9 is equal to c squared. And we get c to be, let's see, it's 4 times 13, so it's going to be 2 square roots of 13 over 3. And that actually turns out to be about 2.6. Okay, so So the foci is going to be 1, 2, some more, 1, 2, and some more there. Oh, wrong way. Oh my gosh, I'm making silly mistakes on this guy here. So 1, 2, and a little bit more. Right there's the foci. 1, 2, and a little bit more. Okay, our major axis is x is equal to 1. Our minor axis is y is equal to 1. And let's finally get the equation of this guy here. Off the center, oh, I guess we should do this too. So 1, because the foci are going up and down off this y-axis, we're going to bounce off -1 plus or minus 2 root 13 over 3. Kind of crazy number. All right, so our final equation is going to be y plus 1 minus x minus 1, both squared, set equal to 1. Our a value is 2, so that's going to be 4. And I'm going to be okay with you guys just leaving this at 16 over 9. We don't need to simplify that any further. That was a tricky one. So last thing we want to do is to be able to look at a graph and then try to write the equation of it. You're going to have to do a little bit of guesstimating with this method here. Let me switch colors because the graph is blue. The center, so we got a vertex here and a vertex here. That's going to put my center right at this point here. So I know my center is at -1, -2. I can see it is an x squared parabola. So it's going to be x plus 1 squared minus y plus 2 squared is set equal to 1. I can see that my a value is 2, so that's going to put a 4 here. Let's try to get a box in there. You're going to need to kind of estimate that out a little bit. Remember, we want the hyperbola to hug along the asymptotes. So if I'm kind of looking to put asymptotes in here, that one works pretty well. So I can see that that is up 2, so this is also going to be a 4. If I look at this one here, again, I'm going to have vertices here and here. That's going to give me a center right here. So I know my center is going to be -3, 1. I can see this is a y squared hyperbola. So it's going to be y minus 1 squared minus x plus 3 squared. We're always set equal to 1. I can count out my a value sitting here, 3, so I do know that's going to be over 9. I'm just trying to look to put asymptotes in there, so you're kind of guesstimating a little bit. Sometimes it helps to get a ruler out. You can kind of straighten things out a little bit. But if I kind of look at that, I'm trying to get a good box going in here. I think if I went about like this, that's kind of fitting along where my asymptotes are going through. So I'm going to say this has a b value of 2, so this would be over 4. And that concludes our final lesson, not just on hyperbolas, but also on conics.